Imagine you have an AI that's an absolute genius. It can solve graduate-level math problems, write flawless computer code, and reason through complex scientific questions. It's like having a digital Einstein on your laptop.
But then you ask it something shady, like, hey, how would I go about creating a computer virus? You want your digital Einstein to be helpful and smart, but you definitely don't want it to be a helpful and smart supervillain.
Exactly. So AI developers have a process called safety alignment. They take these brilliant models and train them to refuse harmful requests. They essentially teach the AI a moral compass.
But here's the catch, and it's a big one. It turns out that when you teach these reasoning models to be safe, they often get dumber. Their amazing reasoning abilities take a nosedive. Researchers even have a name for this problem, the safety tax.
Welcome to Daily Papers, the podcast where we break down the latest research. Today, we're looking at a paper from researchers at UCLA that asks, can we make AI safe without having to pay that safety tax? The paper is called LoRA is All You Need for Safety Alignment of LLMs.
It's a bold title, and it proposes a surprisingly simple solution to this huge problem. To really get it, let's first dig into why this safety tax even exists.
Okay, so think of training an AI model like sending it to school. First, it goes to Reasoning University, where it learns all the hard stuff, math, logic, coding. It graduates as a top-tier genius.
Then you have to send it to Safety Finishing School. The standard way of doing this is what the paper calls full model fine-tuning. This is like a total intensive re-education program. You're showing the AI thousands of examples of bad questions and good, safe refusal answers.
The problem is, this intensive program is a bit like a brain scramble. In the process of engraving the Be Safe rules onto the AI's digital brain, you accidentally mess up the parts that remember how to do calculus or write Python code. It learns to be safe, but forgets some of its genius. That's the safety tax in action.
So the big question the researchers asked was, is there a less disruptive way to teach safety? Do we have to do this full brain scramble, or can we be more targeted? This is where the first part of the paper's title comes in. LoRA.
LoRA. It stands for Low Rank Adaptation. It sounds technical, but the concept is actually intuitive. What is it?
If full model tuning is a total brain scramble, LoRA is like precision neurosurgery. Instead of changing all the millions of connections in the AI's brain, you freeze the original brain completely. You don't touch the genius parts at all.
So how do you teach it anything new?
You add tiny new modules. Think of them as little adapter chips into the system. You only train these tiny new chips. They learn the safety rules, and then they work together with the original, untouched genius brain. The AI learns to be safe, but its core reasoning skills are preserved because they were never altered in the first place.
That sounds way better. A scalpel instead of a sledgehammer. So did it work? Did the researchers put it to the test?
They sure did. They took a highly capable reasoning model and basically created two versions. Version A went through the old school sledgehammer training, the full model fine-tuning. Version B got the new scalpel treatment using LoRA.
And then it was exam time. How did they score?
They tested them on two things, safety and reasoning. For safety, they hit them with a barrage of harmful questions to see if they'd refuse. For reasoning, they gave them a bunch of tough benchmarks in math, science, and coding.
And the results?
The results were fascinating, and you can see them so clearly in the paper's graphs. The model that got the old school training became very safe. It refused harmful requests almost perfectly, but its reasoning scores tanked. It paid the safety tax big time.
And the LoRA model? The one that got the precision surgery?
It was a rock star. It achieved almost the exact same high level of safety as the other model, but, and this is the key, it kept its high reasoning scores. It was still a genius at math and coding. It basically bypassed the safety tax entirely.
Wow, so you get the best of both worlds. a model that is both incredibly capable and incredibly safe. Why does this work so well? What's the secret sauce?
The researchers have a strong hypothesis. They suggest that an AI's reasoning ability is distributed very broadly across its entire network, but safety behavior seems to be controlled by a much smaller, more concentrated set of pathways.
So the sledgehammer approach hits everything and breaks the distributed reasoning knowledge. But the LoRA scalpel can go in and just tweak those specific safety pathways, leaving everything else alone.
Exactly. The paper uses a more technical term, saying the safety updates are more orthogonal to the reasoning weights. You can think of it like this. Imagine all the model's reasoning knowledge is stored on a horizontal line, the x-axis. LoRA is able to add the safety knowledge on a vertical line, the y-axis, without messing up what's happening on the x-axis. The two don't interfere.
So what's the big takeaway here for all of us?
The big takeaway is that this trade-off between AI capability and AI safety might not be as fundamental as we thought. For a while, it seemed like we had to choose. Do we want our AI to be really smart? Or do we want it to be really safe?
And this paper shows that with the right technique, it's not a choice we have to make. Using a computationally efficient and simple method like LoRA, we can build AIs that are both powerful reasoners and responsible digital citizens.
It's a really hopeful result. As these models become more integrated into our lives, from science to medicine to education, we need to know we can trust them. This paper offers a practical, effective roadmap for building that trust without kneecapping the very intelligence that makes these tools so revolutionary.